Hey there, have you ever wondered how some mechanical engineers land dream jobs at Apple and Google and Microsoft? Well, today in this video, we're going to talk about the main 6 courses that I took that led me to Apple and now becoming a CTO at a startup. Hey there, my name is Farhan. I've been an engineer for almost a decade, and in this video, we're going to talk about those 6 courses that I think really fundamentally shaped me to become an excellent engineer. I really believe that these courses shaped who I am today and made me the best engineer that I can be. So stick around till the end. The last one is the most important. All right, let's get started. Number 1, Mechatronics and Robotics Engineering. I actually took robotics engineering in the University of Waterloo, and I think it really helped me stand out from the crowd. That's because it helped me build a fundamental understanding of how systems work in the grand scale. So for example, you're watching me through a phone or through a laptop or something like that, right? They are mechatronic systems. They have electrical circuitry, they have cameras, they have actuators, they have hinges and linkages and all these kind of things built into them. And in this world today, we have all of these kind of products that are multidisciplinary. And so learning about how all of them come together and become a product is super valuable. So I do recommend taking robotics and learning about how sensors are designed, how actuators are designed, differences between motors and actuators, what type of controllers you can use to control different robotic systems and such. It'll really give an upper hand compared to your other peers. What's not important though is learning detailed design of like specific controllers or sensors. Have a high-level understanding. This will help you a lot more than learning deep knowledge in a specific sensor or another. And so having that general high-level knowledge will be much more crucial and beneficial to you. Next is material science, and I do recommend you focus on this course. It's a very important course. I actually didn't like it too much, and I wish I took it more seriously when I was in university. And this is where you learn about different kind of materials, their properties, the differences between metals and non-metals, and crystal structures, lattices, and such. It's super vital because if you learn this, look around you. Everything's made of materials. You're sitting on atoms. You are made of atoms, right? And so learning about how different materials have different properties and what kind of properties they have, how they behave under different conditions like say heat or humidity. Learning the high-level principles of materials will really get you far, and that's because it'll help you figure out what materials you need to choose to design different things. It's not super important for you to learn about processing techniques. For example, how do you anodize aluminum? As long as you know that you can anodize aluminum and what sort of properties come by anodizing aluminum, that'll get you all the way you need to go. And then you can talk to experts in your field to learn more. All right, next is mechanics of deformable solids, and this was one of my favorite courses of all time. It was taught by this professor that I really thought, he's an incredible professor, and I learned probably the most through this course. And some of the fundamental things that you should learn from this course are FBDs, free body diagrams, learn about static equations. And I know that it might sound stressful to you that, hey, these might have been some of the hardest things that you need to do. Design an FBD, solve for it. But trust me, one of your interview questions are going to be, hey, solve this FBD, show me the resultant force here. And so you're going to want to brush up on your FBDs. Additionally, it's super important to know FBDs. Like if you're going to design something, and I do this almost every day, if I'm going to design some new component, I have a rough idea of the size and shape. If I want to select a specific material for it, I'll do a quick FBD and see, hey, this is the kind of load it's going to undergo. And so it helps me design for that and choose the right material, or at least adjust the geometry to be a bit better if I have a limited material choice. Next, you're going to want to learn about stress strain curves, and I do recommend you go really in depth with it. In fact, I will release a video in the future about stress strain curves specifically because of how important it is, and I can go on for an hour lecture talking about stress strain curves, the differences between aluminum and steel and rubber and all that stuff. And you're always going to be asked this question in interviews, especially at these big companies. So learn about stress strain curves, learn about the differences and how the stress strain curve can uncover the material properties for you. And one last topic to talk about in mods is talking about structures and the differences between different structures like trusses or columns or beams, and learning about beam bending equations such that you have a high-level grasp of how to solve for equations like that in case you ever come across them in real life. So learn and get familiar with the equations. You don't need to memorize them, but as long as you have a high-level understanding of how they work so that if you ever need to use them, you can use them. Next is finite element analysis. And although it doesn't seem like it's super important, it is very important that you know how to solve complex systems and create a simulation for you to solve for them. What do I mean by that? Well, we just talked about FBDs, and FBDs are super important, right? But what if you can't solve for that FBD? What if it's a super complex problem? Maybe it's 3-dimensional, maybe the structures are super complex and curvy or whatever. How do you solve for that? Well, that's where FEA comes in. where you can use computer tools to help simulate those different materials and different systems and solve for whether that material selection is correct, the geometry is correct, if you need to add more material, if you need to change a shape or something like that. FEA is super critical, and I do recommend you learn about high-level FEA simulation, learn about using one tool at least, maybe ANSYS, and just high-level familiarity with it. You don't need to go too in-depth. There are going to be experts who are FEA experts, but if you'll enjoy it, you can also go in and become that FEA expert. But high-level FEA understanding and using the tools is super valuable. I do recommend you learn about it. Mechanical machine design. Now, I'm not sure what you call this course in your university. We used to call it mechanical machine design, and the different universities have a different name for it. But let me tell you a bit about what I learned, and then maybe you can find something equivalent to it. In our course, we tried to design a system that solved for a specific problem. So what I mean by that, we were presented with this high-level problem that we had to build a robot. What we had to do was we had to cross this wall, and on the other side of the wall was a package that we had to capture and retrieve and bring it back. Now, the walls are made out of metal, so what most people did was they created these robotic cars that would drive up the wall and down, grab the package and come back. And that was really clever. It's a really good design. We want to take it a step further and design something unique, where we designed a helium blimp that actually took off, went over, grabbed it and came back. And we decided on a blimp because it's a little more stable than a drone. Drones are very hard to program in a very short time. And so within our time limit, we decided to go creative, learn something new and design a blimp. Now, why do I recommend this course? Well, you can see from what I described that it was really fun and we learned a lot, and you can see that you're doing a real life application and building something physical. And you're not going to learn mechanical engineering unless you get your hands dirty. And in some of the previous videos, I talked about how it's important to get your hands dirty, feel different materials, see how they feel, talk to machinists. And this course, you can't get better than that because you are actually going and building something with your hands and finding out what's wrong with it, how to make it better, and how to improve and iterate and like prototype these kind of things. So find a course that's similar to this and learn about how to build robots and products and such. Some other key topics that we took in this course that I do need to mention include learning about gears, learning about bearings, learning about linkages and such, and cam, learning about those moving mechanical mechanisms and such is really key, because most of the world you live in is dynamic and moving. A lot of it is static. But if you have some sort of high-level understanding of how these moving parts work together, you'll be a lot ahead of your peers because you can think dynamically, not just statically. All right, the final one. In fact, this one I actually didn't have a course or at least the course didn't teach me much. This is something I needed to learn, and if you have a course for this, I do recommend you dive really deep into it, and that is CAD, computer-aided design. And it might be surprising to you that I didn't actually learn CAD in university that well. I learned most of it on my own, by myself, tinkering around. I downloaded SolidWorks while I was at university, and it really helped me learn how to design things and appreciate the materials, the mods, everything I talked about before, really learn how to design things in the real world. And I do recommend learning CAD, find a way to learn it, and choose one. Don't learn 5 different CAD modeling software, it's not important. What's important is learning how to design things in the 3D world and how the 3D design on the computer translates into a real physical product in the real world. On top of this, some stuff to consider in design are tolerancing and tolerance analysis, drawings and assemblies, and GD&T. If you can learn these topics, they'll make you stand out far ahead of your peers. In fact, if you can do these topics, you're going to be far ahead of many engineers who are 1 or 2 years into their engineering career. So learn about these topics, find out how you can apply them, find out how you can do some projects with those in them, because in all these companies like Apple and Google and Microsoft and such, they're building real physical products, right? And so you need to learn how to design those, and you need to learn how to tolerance those, such that when you build millions of those a day or a year, you're able to build them and not have parts that don't fit together properly. So learn about those things, learn about CAD, learn about DFM, design for manufacture and assembly, learn about how tolerancing works and how all of those come together to help you create products that are shippable and manufacturable. So there you have it, the 6 courses that I think that led me to success and made me become the engineer that I am today and helped me land a job at Apple. So I hope you found this video useful. Actually, I have a course that I'm starting up called PD Engineering. If you're interested, you can learn more about it in the description. Otherwise, in the meantime, if you want to learn more about PD Engineering in general, you can learn about it here. And if you're interested in entrepreneurship and leveling up your skills to build a startup as a mechanical engineer, as an engineer in general, you can watch this video. Thanks a lot. It was really great talking to you. See you in the next one.